So as you're writing Lewis structures, what you'll come to find is that there are multiple different forms for for many of these molecules. There are multiple possibilities for the Lewis structures, and so even with both of them being correct. And an example of this is carbon dioxide, shown here, where you have two different Lewis structures, and both of them have octets around each atom, and they have the right number of valence electrons, but neither, and so they're both correct Lewis structures, but some Lewis structures are better than others. And the way to find the best Lewis structure is to calculate formal charge for each atom in that Lewis structure. And what the formal charge is it's a calculation that would see what the charge an atom would have in a molecule if all atoms had the same electronegativity. And so I calculate this a little bit different than the way the book does it. So this is how I'm going to teach you to do it. If you find that the way the book does it is more intuitive to you, use that method, because they both will work out for you. But what you do is you subtract from the total valence electrons for the atom the lone pair electrons in the Lewis structure and 1/2 the bonding or shared electrons. And so there's a very simple formula that you can use that I've come up with, and it's similar to the one in your book, but you take the formal charge for an atom is the number of valence electrons for that atom minus the lines minus the dots. So let's go ahead and check out the formal charge for each of these particular atoms. So starting over here, this oxygen's formal charge, we find it on the periodic table in group 6A, meaning it has 6 valence electrons. Then we subtract from that the number of lines connected to that oxygen, which would be 2. Then we subtract from, and also we subtract from that the number of dots connected to that oxygen, which would be 1, 2, 3, 4. And so it would have a formal charge of 0. Do the same thing for this one. We find it in group 4, so it's got 4 valence electrons minus the number of dots, or excuse me, lines, 1, 2, 3, 4, minus the number of dots, which would be 0. So that's got a formal charge of 0. Do the same for this. You'll find it has the same formal charge here. So formal charge, formal charge. Moving over here, we go to this oxygen, formal charge. We start with the total number of valence electrons. So 6 minus the number of lines, 1, minus the number of dots, 6, and that'll end up with a -1 charge. Here we have carbon, so this is oxygen 1. Let's just call this oxygen 2. So oxygen 1. Carbon, we have 4 valence electrons minus the number of lines, so the -4, minus the number of dots, so 0. And then for this oxygen, we have again 6 valence electrons, so this is O2 representing this oxygen over here, minus the number of lines, which is 3, minus the number of dots, which is 2, so this one would be +1. Now remember, these formal charges don't represent real charges, so that's an important statement. They are not real charges in your molecule. Remember, the electrons are shared, and so there are no charges on these atoms. So the best Lewis structure is the one with the fewest charges, or that is the charges with the most number of formal charges closest to 0. One of the things that's important is that you have to put all negative charges on the most electronegative atoms. And so remember, your central atom is your least electronegative atom, so all negative charges need to go on the outside atoms. So that's how to have the best Lewis structures. Formal charges need to all add up to whatever the charge is on that species. So if you have an ion, let's say like NH4+, if you write the Lewis structure for this, the formal charges for all the atoms in this Lewis structure need to add up to +1. So let's look at this example down here. So this down here is the thiocyanate ion. As you see, we have 3 different Lewis structures right here. So the best, we got to figure out which is the best Lewis structure. So right now we're going with the first one. The best Lewis structure is the one with the fewest charges closest, with the fewest charges. That is the most charges closest to zero. Well, down here that rules out this one because we have this atom over here would have a formal charge of -2 as written. This one has a +1 charge. So this one is definitely not a good one based on this first criteria. These down here both have just a single -1 charge on them. Those together are equally good just based on this first criteria. So then we have to put the negative charge on the most electronegative atom. So if we look down here and we look at what the electronegativity is for these two atoms, we see that sulfur is here at 2.5 and nitrogen is here at 3.0. So since nitrogen has an electronegativity of 3.0, we want the formal charge on that, the negative charge on that particular atom, and we want the sulfur to be 0. So this right here is our best Lewis structure. So the formal charge needs to go, the -1 charge needs to go on the nitrogen atom in the structure, and that gives our best Lewis structure.